Alright, so again, we're going to start off with our vertical angles theorem. And again, make sure you know the difference between definitions and theorems. That's what each one says. We have to be very careful and particular about how we go about our proofs. Alright, we are going to be doing 2-column proofs in here. There's also what's called a paragraph proof, which is basically you just write it out as a paragraph. We focus on 2-column proofs. That's my preference. Alright, so start off by drawing your 2 columns. Left side is statements. These are the statements, the facts you tell me. The right side are your reasons. You better be able to tell me why you're able to do that, how you know you're able to make that claim. Alright, what is my first statement always going to be? Given. Right, the given statement. Write it out exactly as you see it. Angle 1 and angle 3 are vertical angles. You can use abbreviations. And what's my reason? Given. Oh, good job. Alright, so we're trying to show that 1 and 3 are congruent. They look congruent, right? But how in the world do we figure out that they truly are congruent? They are supplementary, and these are supplementary. 2 doesn't change. 1 and 3 must be the same. So we actually are going to end up proving congruent supplements theorem within our vertical angles theorem, but it's okay. It's going to be a grand old time. All right. So we want to get to the fact of showing that 1 and 2 are supplementary and 2 and 3 are supplementary. But how do I know they're supplementary?
They form a linear pair.
They form a linear pair. So we need to first state that they are indeed linear pairs. All right. So angle 1 and angle 2 are a linear pair. Form a linear pair. And likewise, angle 2 and angle 3 are a linear pair. How do we know that's true? Definition, right. The definition states that their non-common sides form opposite rays. We see that from the picture, so we know it because the definition. So definition of linear pairs. Alright, now that I know they are linear pairs, what can I say? They're supplementary. Good. So now I can go ahead. Angle 1 and angle 2 are supplementary. I'm fine with you saying sup. Angle 2 and angle 3 are sup. And how do we know that is true? What is it?
Definition of supplementary is something with linear plates. That's the postulate.
So we have to decide. Is it a postulate or is it the definition of supplementary? What is the definition of supplementary?
2 angles and 180.
Right. 2 angles that add up to be 180. Do we know that they have to be 180 yet? No. So that's not how we got there. We got there by the linear pair postulate, which says linear pairs are supplementary. Okay. So linear pair postulate. If you forget the title, that's perfectly fine. Just state what it says. You can write instead, linear pairs are supplementary. Perfectly fine. God bless you. It was a muffled sneeze. Alright, so by linear pair postulate, we know those 2 sets are supplementary. Now that I know they're supplementary, what do I know? The measures add up to be 180. Equation here. The measure of angle 1 plus the measure of angle 2 equals 180 degrees. the measure of angle 2 plus the measure of angle 3 equals 100. We're not using congruent supplements theorem yet because technically at this point we haven't proven, we don't know that we don't know about it yet, so we're going to be proving. All right, so how do we know this to be true? Good. Definition of supplementary angles. We know they're supplementary, thus we know their measures out. Okay, so we somehow need to get 1 and 3 to get in the same statement, right? In the same equation. So what do you think we can do? Elise?
Angle 1 plus the measure of angle 1 plus the measure of angle 2 equals the measure of angle 3.
Very good. How do you know that's true?
Because they're both equal 180, so if they're both equal the same thing, then they must equal each other.
Right. So measure of angle 1 equals 180. 1 plus 2. Measure of 2 plus 3 equals 180. So we can then take, essentially what we're doing is taking this piece here and substituting it in for 180, right? That whole thing. Now, I recommend as you're doing proofs to go ahead and take a look at your statement up here. My final statement is 1 is congruent to 3. 1 is on the left, 3 is on the right. So let's make it so that when we set it up, 1 is on the left, 3 is on the right. Otherwise, we have to do an additional step, that symmetric property, and no one really likes that. So anticipate, save yourself. If you have to do an extra step, that's fine. All right. So we have the measure of angle 1 plus the measure of angle 2 equals the measure of angle 2 plus the measure of angle 3. And how do we know that's true? Substitution. Good, substitution. We could use something else as well. Anybody know what it is? We could do the trans. Yeah, it's technically also transitive property. Transitive property. Substitution. Transitive property is really just substitution twice. So here we have 1 and 2 equals 180, and 180 equals 2 and 3, so 1 and 2 equals 2 and 3. So that's transitive, but when in doubt, say substitution. So you could have also said transitive. Either one is acceptable. Transitive. Okay, we're getting closer. What do you think we do next?
Subtraction.
Good. Subtract the measure of angle 2 from both sides. That's my next step. Measure of angle 1 equals the measure of angle 3. Oh, and how did we do that? We subtracted, so we're going to go with subtraction. Co. I always forget my C. Subtraction. 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 All right. Hey, are we done? No. No! I got one of you tricked. Why does it have to be? They have to be congruent. Do we have angles congruent? No, we have measures are equal. How do I get it to be angles are congruent?
Take away the measure.
Change it. So if the measures are equal, the figures are congruent, and how do we know that's true?
Because the measures are equal to each other.
Does anybody remember what it is?
Oh, the definition of congruent angles.
Yes, that's exactly it.
I just made it. What? I didn't even know we learned. I invented it. Yeah.
Angles. Back when we learned the vertical angles theorem, right angle congruence theorem, all of that, we learned it at the bottom. So whenever you switch from measure to segment or segment to measure, Its definition of congruent angles, or if we're talking about segments, definition of congruent segments.
When I was really little, I thought I invented brushing the back of your teeth.
Alright, they are the same. So we got our proof. Good. So you've just proved the vertical angles theorem, which is so important for geometry. Alright. So angle 1 and angle, thank you. Angle 1 and 3 are supplementary. Angle 2 and 3 are supplementary. So write in our statements. Yeah. And reasons. And we all know our first statement. Angle 1 and 3 are sup. So, angle 2 and angle 3 are sup. Supplementary. And that is given to us. Here, girl. Supplementary. Supplementary. Yes, Logan? Yes, I want you to put the numbers just because we can, sometimes we'll have proofs that can be anywhere from 5 steps to 15 steps. And so,
What?
oh yeah, come on. So I want to make sure that I can follow your flow. So actually this is a good time to talk about, it is important that in all math classes, but especially in geometry and especially with proofs, that we are neat and organized with our work. Numbering. Some people like to draw lines between each step. That's not necessary, but if that's what you prefer, great. Also, we have control over how large we write, to the most part, except some of us have broken wrists and we struggle with that. But the rest of us have control over how large we write. So don't start writing like this. Angle 1 here, angle 1 here, something there. You're going to run out of room real quick, okay? So be nice and neat and organized. Make my life easier. All right. So what does it mean if they are supplementary? What do we know about that? Good. The measures add up to be 180. So let's go and write that. Whoop. The measure of angle 1 plus the measure of angle 3 equals 180 degrees. The measure of angle 2 plus the measure of angle 3 equals 180 degrees. Good. Definition of supplementary angles. We know that is true because by definition. Definition. Def of sup. Angle side. Alright. Any thoughts as to what we can do next? Ready?
Angle 1 plus angle 3 equals angle 3 plus angle 2.
Very good. The measure of angle 1 plus the measure of angle 3 equals the measure of angle 2 plus the measure of angle 3. The measure of angle 1 plus the measure of angle 3 equals the measure of angle 2 plus the measure of angle 3.
So the rest are the same as they call.
How do we know this to be true?
Because they equal the same thing. So you can set them equal to each other. So it's the definition of substitution.
Substitution or transitive property. Here we could use either one because technically, so they both equal 180, right? So what I'm doing is I'm basically taking this and substituting it in for 180. Or if you think of transitive property, 1 plus 3, or 1 and 3 is 180, 180 is 2 and 3, so 1 and 3 must be 2 and 3. So this is this, this is this, this is this. So either one, substitution or transitive property. When in doubt, just say substitution. substitution. Or transitive property. You never have enough room for this. Right. Now what? What are we subtracting? The measure of angle 3. This is 1 unit here. So the measure of angle 1 equals the measure of angle 2. And what? Subtraction code. CT.
It looks like M4. Measure of angle 1. Yeah, it looks like measure of M4. And then like.
That just looks weird.
Yeah, I didn't see that.
Now, yeah, you messed us all up. When I look at that, I see measure of angle 1. Are we done?
No.
That's something congruent. Yeah, we gotta go congruent now. So our last step, angle 1 is congruent to angle 2. And how do we know that? Good definition of congruent angles. Are we done?
Yes, sir.
When we did proofs in college, after you would get to your final conclusion, although we would write paragraph proofs and sometimes they were really, really, really long. Some proofs that my husband did were like pages long. But at the end you would write QED, which is something Latin-y or something for it is finished or it is proven or something like that. I don't know. We don't do that. You just have to make sure that your final statement matches the final statement. All right. Questions on that? Now, what does the bottom of your paper say? Yeah, so congruent complements theorem is extremely similar. What would change?
Instead of supplementary.
Right, instead of them being supplementary, they're complementary, which means their measures would add up to be 90. Okay, but I'm not going to make you go through it all again. Okay, backside.
One other question.
Yes.
So if you don't show enough room, like make 4 different columns and have one be statements and the regions and then statements. And
Like where you just kind of basically air it up on the edges. Yeah, that's fine. Yeah. All right, the right angle congruence theorem. Oh, that should say theorem on the end. Where did my theorem go? Please write in theorem. All right, so here we are given angle x and angle y at right angles, and so we have to prove that they are congruent. Seems pretty self-explanatory, right? But how do we know that these are congruent? What's the process for you guys? Go ahead. Stop.
They're right angles and
Good, so they're right angles, which means what? They equal 90, and does 90 equal 90? Yeah, so then if their measures are equal, then we know that they are congruent. So that's going to be the idea we go through. Again, when you get information, go ahead and mark it in your diagram. They've already marked for us that those are right angles. Also, come up with a brainstorm, a general idea of where you're planning on going with it. I like to look at a proof and kind of think, all right, how could I do this before I start writing it down? So at least then I know where I'm going and it's easier to get there, other than just starting to be like, maybe let's add some stuff together. Well, why? Make sure you actually need to add stuff. Okay, so let's set up our 2 columns here. Statements. Reasons. And our very first statement, angle x, angle y are right angles. That's given to us. think it's probably like 3 or 4. This one's a shorter one. Alright, so now that we know they're right angles, what else do we know? Right, the measure of each one is 90 degrees. 2. The measure of angle x equals 90 degrees. The measure of angle y equals 90 degrees. How do we know that is true?
Right angle.
Good. Definition of right angle. Now, anytime you are doing proofs, if you have a just 2-step proof, you think you've proven it in just 2 steps, given and the conclusion, that meant that you were supposed to have proved what you just did. So, for example, I've had in years past where students write, x and y are right angles, given. Angle x is congruent to angle y. Right angle congruence theorem. That's what you're proving, okay? So, even if it didn't state it up here, if it said prove that and you just had 2 statements, the given and then the prove, and that's it, go back. You were supposed to have proved that theorem, so you can't use the theorem to prove itself. That's circular reasoning. We're not going to go down the circular reasoning road. So we are proving right angle congruence theorem. I don't want to see step 1 and then it say angle x is congruent to angle y by right angle congruence theorem. That's what we're trying to prove. Okay. Typically, we'll have at the top, you are proving such and such. But if it's not there and you have a 2-step proof, go back and do more. The shortest you'll ever have is 3. Okay. All right, now that we know they're equal to 90 degrees, what can we do to get them incorporated in the same statement?
Equal to each other.
Yeah, the measures of the angles are the same, so we can go ahead. Right, the measure of angle x equals the measure of angle y. How did we come to that? Good. Substitution. Can we use transitive here?
Yeah.
Substitution. So x is 90, which is y, so we do technically have transitive here as well. But again, when in doubt, do substitution. I'm going to fit it in. Okay, are we done?
No.
One last thing, what do we have to do? Good. Angle x is congruent to angle y. And that is?
Congruent angles.
The definition of congruent angles. Do you have to what?
Like the way you say it.
What side of the angle side?
If you want to write out congruent angles, that's fine.
How to do that. Like, are we on
Yeah, you can write like that on this. Yeah. Alright, any questions on this? Alright, so that one wasn't too bad either, right? So we've proven some theorems. Now let's actually get a different scenario. We're not going to be proving a theorem. They're giving us different information, new scenario, and we're going to prove this statement. But we need to draw a picture with it. So you're going to draw the following picture. The picture will be given to you, but it is not easy to create said pictures. So instead of spending an hour creating it, I decided to let you guys practice your drawing skills.
I have a ruler here.
All right. Also, this should say AEC. I apologize. AEC. What'd you say?
Good job, Zoe.
All right. So our picture, we have. This is not a right angle I'm drawing, just so you know. And let's see. All right, so we've got A.
Do you have to draw this?
This is what you're drawing. Yep.
Have like a specific leaves or what?
D.
We just like draw the bars of each way.
So on your sheet,
Just draw it right here.
So it's basically just draw a random angle with 2 lines in it.
Yeah.
if you want to make it obtuse, you can.
Anything.
If you want to make it more fanned out. Now, this is angle 1, 2, and 3. So for your visual sake, try to make 1 and 3 similar since their measures are equal. But obviously it doesn't have to be perfect. So, oh, perfect. So I want to make a note here while you're drawing your picture for this. If it looks like it's a right angle, but it does not tell you it's a right angle, and there's no notation indicating right angle, can we assume it's a right angle? No. If it looks like the angles are the same, but it doesn't tell you the angles are the same, and there's notation indicating the angles are the same, can we believe the angles are the same? No. On your test, there were some of you. Say this was x plus 3, and say this was 5x minus 7. You went ahead and set these equal to each other. Do I have any indication these are equal? No. What do I know? The measures add up to 90. They did give us it's a right angle overall, but we don't know these are equal. So be careful. Don't be assuming information about your pictures. All right. Are we good with our drawing here?
Yeah.
Awesome. All right. So let's go and set up our 2 columns. Statements. Reasons. And we have given to us the measure of angle 1 is equal to the measure of angle 3. For those of you that are curious, this will be about 5 steps. Okay, just for your space sake. And this is given. Okay. Now, whenever we encounter a proof, we should read the information given to us. Go ahead and mark it in your diagram to help you out, and make sure you understand where you're trying to actually go with this. So, they tell us that angle 1 is equal, the measure of angle 1 is equal to the measure of angle 3. How can we mark that in our picture? Alicia?
The little curvy marks.
Yeah, the little curvy marks. Angle 1 and angle 3 should have the same amount of curvy marks. Yes, Paul?
Do they have like an actual name?
Oh, that's a good question. If they do, I don't know what it is. Little arcs is what I call them. All right. So this lets us know that they have congruent, that they are congruent, they have equal measures. Now, also, let's take a look at what we're trying to prove. I'm going to do a little bit of highlighting here. Angle AEC. AEC. What is AEC made up of?
Angle 1 and 2. Angle 1 and 2.
Right.
Oh, I get it.
Okay. And we're trying to show that that amount is the same as VEC, right? What is VED made up of? Good. And we know that 2 is going to stay the same no matter what, right? And we also know that 1 and 3 are the same. Do we believe that they indeed are equal? Yeah. Good. It's always good to make sure you actually believe the proof before you start. What tools do you think we can use to help us in our proof? So like what postulates or theorems do you think can help us out?
Angle addition.
Yes! Angle addition postulate. It's made up, our overall overlapping angles are made up of the 2 small ones, right? So maybe we can go down that road. So our thought process right now, yeah, we do believe that we see 1 and 3 are the same. 2 doesn't change. So maybe we can set it up with angle addition postulate and then do some substituting and show that it's the exact same statement, right? All right, so next. So the measure of angle AEC is made up of the measure of angle 1 plus the measure of angle 2. Right? Since we're going to be doing angle addition postulate for both of them, we can go ahead and use that in the same step. It's the same reason, so we can use the same step. So let's do it for our BED as well. Measure of angle BED equals the measure of angle 2 plus the measure of angle 3. Do we agree?
Yes.
Okay, good. And how did we know that? Good. Angle addition postulate. You can put add. Yeah, you can put post. Awesome. Post.
Awesome.
Alright. So we need to get, for our proof statement, for them to be exactly the same, right? Right now, are these exactly the same? No, they're close, but they're not exactly the same. What do we need to do?
I don't know.
There are different equations.
Okay.
There are different equations, so how can I modify one of them to be exactly the same? Yeah, change. Remember, measure of angle 1 and angle 3 are the same. So could we replace one of these? Yeah. I'm just gonna do the first one.
So if I know what you're about to do could be substitution, but could you also say given for that because the given statement is what helps you prove that?
No, because given is just simply stating this. The act of substituting it in is substitution. Does that make sense? So the given is because we have the given, we know we're allowed to do substitution. But the what our action is substituting. Okay. All right. So you can do BED if you prefer. I'm just going to do AEC. So the measure of angle AEC. So again, since 1 and 3 are the same, I'm going to take 3 and replace it here. It's the measure of angle 3 plus the measure of angle 2. And that would be substitution. So this is one where it's actually just substitution, not transitive property. Just substitution. Okay, now in order to set them equal, they have to be exactly the same. Are they now exactly the same?
Yeah.
Are they exactly the same? You're not going to like this step. Are they exactly the same? No. But do we know in the world of math that they are the same? How do we know they are the same? Commutative. Good. So before you can set them equal, they have to be exactly the same. So we have to rewrite this now. Measure of angle AEC equals the measure of angle 2 plus the measure of angle 3. Or you could have rewritten here BED to be the same. So they have to be exactly the same before we can substitute. And that would be commutative property. Now, if you could have anticipated this, and then up here in step 2, if you were thinking far enough ahead, you could have said, hey, I want to make sure that these match up so I don't have to deal with that commutative property again. So you could have, when you wrote out your measure of angle BED, you could have said it's 3 plus 2. Or for AC, you could say 2 plus 1 to make sure they line up. So if you had the foresight for that, great. If not, it's fine. Just do commutative property. Okay, now are they exactly the same? Great. Now we have this and this are the same. So what can we do? Good. Now let's think before we start writing this down. Which one do we want to come first? Yeah. Otherwise, we have to do symmetric property in the end. which you can, it's just an additional step. So I'm going to start off measure of angle AEC is equal to measure of angle where I want to be, asleep. And how do we know this? Substitution. Do we have transitive here? Look at it. Do we have substitution? Yeah. AEC equals 2 plus 3, and 2 plus 3 equals DED. So AEC equals DED. So substitution or transitive property. I've been looking forward to that all class.
Well, you nailed it.
Oh, thank you, thank you. I thought it was the last proof, but then it wasn't. Like, oh, next one, next one. Okay. Do they match?
No.
Yeah, no congruent this time. You thought I was going to make you do another congruent statement. Okay. Questions on this one? Yes.
If you were to like the two, the measure of 2 and the measure of 1, would you also
If when you first state it, you start off with it being switched, nope, you're good. Yeah, so that's where if you think ahead enough, you could save yourself a step. But if you forgot, you can always. Oh yeah, yes. You guys are on good to the commutative, and you're like, no way, Jose, and go back and change it. All right, any questions on 4 of them? All right, let's take a look at that.
The last one.
Yeah, we're gonna draw another picture. It's a nice picture.
Do we have to draw?
It's in general, you will not be drawing pictures. It just takes a ton of time to draw the picture. And last night it was already late, so like they can draw their own. I didn't quit. I anticipated because you guys need to know how to draw pictures. Also, it's important that you guys understand too, to remind you that our angles, remember your vertex is always that point there, things like that. Those are some little things that because over the years we've given you so much printed stuff, some people lose some knowledge because you never draw your angles. Alright, so our picture here, we have 2 segments that are intersecting. Hey, I'm going to actually use my line diagram here. Check this out.
Do we have that?
Yeah. Oh, you don't know. Oh my God. You can learn how to draw.
Are you kidding out? Does that look decent?
It's supposed to be equal, like everything. Yeah, it's supposed to be.
It is supposed to be. Hold on, let me move my pictures.
Wait,
So many possible scenarios here. Maybe I should move it like that. Like that. I'm sorry. This is the information you want. Okay, so we have our S is the intersection point.
How do you know that?
I'm giving it to you. It's the picture that would be given to you. R S T.
I have a feeling we did this for
These are line segments.
It looks like we did it for homework.
It's for homework.
So we have 2 intersecting line segments, and for your own visual sake, notice the given to us is RS and SP are congruent, and then SQ and SP are congruent.
You're so
Yeah.
Good.
Good, good, good. All right. Are we good with our picture? Okay, so let's take a look at the information they gave us. The measure segment RS is equal to measure of segment SP. What can we do to draw that notation in our picture?
Fashion mark.
The fashion one.
Yeah. I call them tick marks.
Fashion mark.
Alright, so from R to S, it's the same distance length measure as it is from S to P. So they should have the same amount of tick marks. And Q to S, it's the same as S. Now they want us to prove that the whole segment, RT, is equal to the whole segment, QP. Do you agree with that?
They add up.
They add up, right? What do you think we're going to use?
Segment addition postulate.
Segment addition postulate. The idea is similar to our last one, that if we have the same pieces added up, it should equal the same thing in the end. Alright, so let's get our proof set up here. For those of you that are wondering, it's about 4-5 steps.
Say Tori.
Girl,
We should all be writing down our 2-column thing here. Okay, Speedy Gonzalez's. Alright. Our given, the measure of segment RS. Hey, what does this notation mean? Measure of, which is the same as distance, length of the segment, right?
equals.
The measure of segment SP. And we have the measure of segment QS equals the measure of segment ST. That is our given. Alright, now as you guys said, we're probably going to head towards the segment addition postulate direction. So let's go ahead and set up our segments. And remember, segment addition postulate, well, let me first write down that. Alright, so we're trying to get to the whole segment RT and the whole segment QP. So the segment, measure segment RT is made up of, good. Okay, so remember segment addition and angle addition? It could also be written as, if I wanted to, RS is equal to RT minus ST. Remember that? Just so you know, just a reminder that sometimes we'll use it in that format. Okay, but here we want straight addition. Okay, and then our other piece, Q. What if we actually wrote our Q's like that?
I would think it's like
Looks like a balloon.
I can't see. It does look like a balloon.
Oh, that's so
Fancy.
nice.
Thank you.
I know. It looks like egg with meat. Yeah.
Isn't that all cartoon? Like, I feel like it's a Looney Tunes or somewhere. Where
I
there's-
think I have a thing that hops around.
Oh, I've seen that.
Oh yeah.
Real life ducks that you want.
Yeah.
Oh,
The real life fake ducks that you Alright. So our entire segment Q, P is made up of, our QS and SP. We could anticipate here, but we're just gonna go. Okay? And how do we know this?
Segment addition postulate.
Good. Segment addition postulate.
I want to write pasta.
Say again, post.
Pasta. Pasta. You get pasta. I want a pasta. A lot of pasta.
All right. Thoughts on what we should do next? Alright, Kylie says substitute. I forget already what you said.
Substitute QS for ST. Wait. No.
So we want them to be exactly the same, right? Thus we'll know they're equal. Are any of the chunks the same right now? No, but we do know RS is the same thing as SP, and QS is the same thing as ST, right? So let's just change both of them on one of our equations, and then we'll have to do something with that. What do you want to change, RT or QP?
QP.
I heard QP loudest, so I'm gonna go with that. All right. So instead of QS, let's put in ST. So see that QS is ST, so we're substituting that in. And instead of SP, RS. And split. Alright, this is what? Substitution. Is this transitive? No. We're taking one piece, putting it into another. Substitution. Alright, I'm going to go ahead and do my commutative because I didn't anticipate properly.
No, wait for a second.
Commutative. Rough. Do they now?
Yes.
Skip it if we already did it before.
Now we said it equal to each other.
All right. QP. Not a space.
It's like the
Click on one of the
I don't want it too thick.
Is there like a squiggly one?
All right. What is this the exact same as?
That one.
You can do it with smiley faces too.
Yes, the smiley faces are a little obnoxiously large.
Can you do it?
Oh, you can do it.
All right, going back to normal. What are we going to do next?
RT equals QP.
What should we start with? Let's start with RT. Since the proof statement starts with RT. All right, the measure of segment RT is equal to RS plus ST, which is equal to
QP.
the measure of segment Q.
The last
Yeah. Should break this. He's more in mid-jump. All right, and what is our reasoning here? Substitution. Can we use transitive here?
Yeah.
Yep. Substitution / transitive. You don't have to write both. You can choose one or the other. When in doubt, write substitution.
None of us are ever gonna write transitive.
All right, questions on that? Okay, so go ahead and get out worksheet 5. Whether you did it or not, whether it's correct or wrong,
So much stuff between English and Latin. We got like worksheets over the last 2 days.
everything's wrong.
Worksheets. I know. Zoe, I feel you.
I don't understand anything else.
Why know you killing so many trees?
Hold on a second.
That was like something
I think I get awards for the most wonderfully colorful ever taught.
Alright, worksheet 5, get that out. Alright, worksheet 5. Looks like this, right? So we're just going to go ahead and hit a couple of them. You might see some overlap from worksheet 5 and what we did in class today, but hopefully not too much. Okay, so here, and your homework is going to look similar to this. You do have a good chunk of homework tonight. It's worksheet 6 and 7, but like worksheet 7, it's stapled, but it's only one proof on each page, so it's not as much as you think, at least.
Worksheet 5 homework.
So last class homework was worksheet 5, but if you saw the announcement on Blackboard instead, I want you to watch the video. But if you didn't worksheet 5, great. If not, it's okay. We're gonna do it throughout our remaining classes.
Okay. So the homework for the standard part, it's okay. I just say,
Yeah, you're fine.
okay.
You're fine.
Without flashing this one.
So homework tonight is worksheet 6 and 7. You'll be getting that separately. Yes, Paul?
Seven, it's one for one each page, right?
For worksheet 7, it's stapled. There's like one per page.
15 steps per.
I think it's 5 or 7.
Okay,
It's gonna. They're very similar to this, where there's some filled in and some that you have to fill in. But you will be required to do proofs completely on your own without some steps given. Okay, so this is kind of helping you transition to it. All right. Also, while we're on it, when you look at your assignment sheet, what's happening next class? Quiz over, yep, proofs. So make sure you are doing these. Come see me if you have questions. We will, next class is review / a quiz. So we'll start off going over it, ironing out any issues we're having before taking the quiz, and then just doing some more practice with it. Okay?
So we still have lunch. Evan.
Yeah, we're still gonna have lunch for you next class.
Just
Logan, if you would get your worksheet out and join us. All right. So number 1, we're just gonna get through as much as we can. It says given segment, the measure of segment AD is equal to 2 times AB plus BC. Interesting. Prove that this chunk, prove that this piece is equal to this piece. Okay? Now it seems to make sense, right? It says that the whole segment is BC plus 2 times this. Yeah, and if these segments are the same, 2 times it, so it makes sense, right? So they've gone ahead and given us a given, it's filled in. Step B. AD equals AB plus BC plus CD. A little bit tricky here. What? Yeah, where did this come from? Segment addition fraction. Good. So it's not always going to be previous step to this step. Sometimes you're identifying information. So the whole segment is AB plus BC plus CD. So it's good. Segment addition fraction. Okay. And what did they do from B to C? Right, I see said substitution transitive, but what actually happened? What did they substitute?
AD plus BC.
Good. So here's AD. They took this guy and substituted in for AD. So we have basically step A and B. That's our substitution or transfer. Are you following so far? Alright, now, so again, those beginning steps, sometimes they relate, sometimes not, because sometimes you're pulling other information into your problem. But generally, as you work further down, you're typically working from step to step to step. Okay? Not always, but typically. What's happening here?
Subtraction times 2.
What are we subtracting?
A bunch of stuff.
A bunch of stuff, yes. We subtracted BC, so those end up canceling. And when we subtracted one segment or measure of segment AB, that left us with a single one here. Good. So that is subtraction. Okay, and then D to E, that's definition of congruent. Okay. Oh. I was trying to figure out my congruent accurate. He probably is honored by it. Alright, any questions on that one?
Sorry.
What are we stuck on? Oh, Edgar Allan Poe, Subtraction Poe.
Sorry.
Edgar Allan Poe was a writer, poet. Now we only use his last name Poe.
All of his poems.
Sorry.
Do you think the Joker's in
You can ask after class. Alright. Number 2. Given B is between A and D, as the picture shows, C is between A and D, prove that segment or measure of segment AB plus measure of segment BD is equal to measure of segment AC plus measure of segment CD. Alright. They gave us all those words. Alright. AB plus BD equals AD. Segment addition, right? This plus this equals the whole thing. Alright, what about AC plus CD equal AD? What would that be? Also segment addition. Now when you're writing your own proofs, because it is the same, you're doing the same action, you could have listed it as one step, you know, like we did in class. Yeah, like we did earlier. Alright. What about step D? Yeah. Symmetric property. We just switch them. Symmetric property. I don't know why there's an awkward semi-line, semi-not, probably from being copied. You can see there's specks all over, so that is not supposed to be. Symmetric property. Alright, and then what about step E? Yeah, they simply, now that we have AD on the left side and this on the right, now we can substitute this in for AD on the left. Or sorry, yeah, we're substituting for 80, so now we have that. So substitution. Alright. Questions on that one? Alright, I want you to try number 3. While I pass out your homework to you.
What?
Wait, this is homework?
I guess you just record what I say, so I can just play it back.
Yes, we should.
Great.